right. Ratan, you don't want to show your face? You look good.
I can turn on my camera. So
Ratan hates it. He's got to hide that cute face.
Okay, sounds good. Sounds good. All right. Welcome, guys. Thank you for joining this recorded session. For the first time ever, we are going to make a video out of this and upload it to some social networks, YouTube, LinkedIn, and possibly others. So thank you very much. Maybe first step is that you introduce yourselves, Trent, and then Ratan, maybe.
Yeah, my name's Trent Tully. I'm the founder and CEO of the Venue app, which is a platform to help people find things to do near them using generative AI. And I graduated Boston College in 2023, currently reside in Austin, Texas. And I'll let Ratan introduce himself.
hi everyone. I'm Ratan. I'm the lead developer at Venue. Uh, well, like Trent mentioned, we've made an app that helps people find things to do near them. We're using AI to help uh, search particular points of interest and deliver whatever, like an itinerary of things that are happening around a particular user. Really excited to be a part of this, Metaspex program.
All right, thank you. Trent, maybe you can complement what Ratan said about Venue and what you are planning to do and maybe especially around technology.
Yeah, absolutely. So Venue, the initial idea of what we were trying to do is we wanted to figure out a way for people to create plans with their friends. We want venues to be able to see how people are making plans at their venue. We wanted them to be able to see how customers are interacting with their venue, with their space, or with their event. So we want to create a platform to do such, manage interactions between users and venues and people who we may be promoting within the app. So we want to build a way to kind of archetype and architecture out those intricacies and have those events be able to be kind of one-one associations so we can see real-time action.
Very good. Excellent. And we are very, very happy to work with you guys. You are a treat on an everyday basis. So it's been a blast for us to work with you. So here's what's going to happen. We're going to spend more or less, give or take, 1 hour together. We are going to achieve a few things. So it's really hands-on programming using Metaspex. 1 hour is not much, but I guess that watchers will be able to extrapolate what you can achieve in a day, in a week, in 2 weeks, or the entire Venue application, which is from memory 290 web services, took a bit less than 3 weeks to build. So people will be able to realize, I guess, that we can indeed achieve such a thing, which is to date unheard of. Even promises of Gen AI do not promise to deliver a 290 web services application within less than 3 weeks, which is production grade. I mean something that you can really push to the cloud. Something that is important is that technically the setup on Venue is that you're running the backend, the Metaspex backend in AWS. It's using one core. It's only a 60 megabytes binary. And you have an app, or apps, I should say, that connect directly to the backend. And correct me if I'm wrong, you have one app for iOS and one app for Android, and your users can use both to organize the events and participate to events. What we decided to do today is to help you track the Venue owners as prospects for the Venue platform, because it's a multifaceted platform. It's not just you and me trying to organize a birthday as something like this. It's much more sophisticated than this. So maybe I let you introduce, Trent, what we are trying to achieve, which is modest for today, obviously, but still, I hope will be impressive.
Absolutely.
What we would like to do is to start something like a CRM. That's the name for it. So it means that you are from time to time interacting with Venue owners. And when I say from time to time, it must be much more often than this, I guess. And Venue owners do not necessarily sign immediately for the Venue platform. So you need to follow them up, and you have various interactions. Some of them sign immediately, some of them after a few interactions. So the idea of the platform is to create these kinds of prospects and record all the interactions that you have with them. Of course, there can be many other features that we can add. I think that's plenty enough to show how to use Metaspex today, and how concretely hands-on programming with Metaspex is happening. All good?
Yes, sir.
Okay. A little warning for the audience, and maybe 2 apologies. The first warning is that we are going to see maybe 5% of Metaspex. So 5% is not much. I'm always in fear that people after a short while think that they have been putting their arms around Metaspex. It's not going to be the case. It's a small fraction, but we'll see that with 5% of Metaspex, we can already achieve a number of things. And the apologies is that we are usually not mixing these kinds of discussions with hands-on programming. As you know, we are discussing business, and then offline we do the Metaspex programming. It's not because it's long, it's because it's boring. So I apologize for some people in the audience. They will find it boring at times, and I think there is nothing we can do about this. And the other apology I need to make is that I'm going to over-explain things for some people in the audience, and I'm going to under-explain things for some others. That's all we can do for now. There will be subsequent videos we do which are going to drill down into more detailed aspects of Metaspex, but for the time being, that's what we want to achieve. We are going to develop an ontology, and we've been talking about ontologies for a very long time now. We are going to develop payloads, so things that are carried through web services, so queries and replies. And we are going to develop something like 10 web services, which is a substantial amount. I don't think that any technology today can allow to develop 10 web services in 1 hour. It does not exist, so Metaspex is able to do this. And what we are going to do is not a proof of concept. When we deliver something with Metaspex, it's the real deal. It's something that you can already push immediately after to the cloud, that exhibits very good response time, in the millisecond real-time response time for each of the web services. So let's start. And I'm going to share my screen. It's going to be a very crude, empty editor. So it's a simple code editor. For those of you who know that, it's Emacs, very crude, simple Emacs. And I'm going to develop everything inside only this file. So it's not going to be multiple files. We can actually develop a Metaspex application using many files, but for this type of application, 1 file will be enough. In the case of the Venue application with 290 web services and a pretty beefy ontology, the entire ontology is in a single file. So it shows that even a pretty high complexity of an application fits in just a few files. So let's start. I'm going to start with the ontology. So I'm going to put a small comment saying that it is an ontology. Can you read, by the way? Is it clear enough?
Yeah.
Yep. Okay. Very good. So what is an ontology? An ontology is the same thing as a data model. We are going to describe what we are going to handle in the application, and that's essentially prospects and interactions with these prospects. So I'm going to start with the prospect. What is a prospect? And I'm going to define here, almost in a declarative manner, what a prospect is. So a prospect is a type, and this is why I'm using the class keyword. So a prospect is a type, and I'm going to use a Metaspex construct called root. So root, which is here, comes from the Metaspex library. So I have to import this, and I am going to import it by writing this. So I've already prepared a compilation environment where all these things are accessible, and I'm able to actually compile everything that you see as soon as it's going to be correct. So what is a root first? As you know, at least you, the new people, you know that, and maybe the audience does not know this. Metaspex relies on document databases, also called NoSQL databases. So we support Couchbase, we support MongoDB, we also support CouchDB. In your case, you're running on Couchbase. I think it's right. And a document database, for people who don't know what a document database is something that serves files. It serves document, but the document essentially is a file. So it's as if you had a set of files stored somewhere on disk, and each of these files contain a so-called JSON document. JSON document is a structured format whereby you have keys and values, and a JSON object can contain sub-objects, and these objects can contain other sub-objects. It's a bit like an HTML page, if you wish, for those of you who don't know what a JSON document is. So here we are saying that the prospect will be stored in a separate document. This is why it's a root of a document. And everything that a prospect contains will be stored in this document. And it's not going to be just one object, it's going to be several, as we are going to see. So next thing I need to do is to use a macro coming also from Metaspex. And I'm going to put a string here, which is prospect with an uppercase. It could be anything I want. As long as it is chosen unique among the different types that we are going to list. So I've decided to use this string, and this string will appear inside the database. So I have selected my string. Then I'm going to write a version number. This is the first version of this document, or this type in the ontology. And every time we change the layout of a prospect, we'll have to increment that version number. For the time being, it's 1. I'm repeating here root, and then I am going to list what a prospect contains. So for the time being, nothing, but I'm going to ask you a few questions, and depending on your answer, I'm going to add stuff there. I'm writing a public section and a private section. This is for visibility purposes for the code that we are going to write. As you can see, this is code. Technically, it's pure C++ code. So the first thing is, how do you want to identify prospects? Do you want to identify with simply a name? Do you want to have their company name? Do you want to have a last name? Do you want to have a first name as well? Tell me what you need, and I'll do what you need.
And just confirming, is this for the people or for the venues?
It's for the venues. We are not going to model people for the time being. Let's consider that we could do it, but let's consider that the prospect is a venue prospect.
Yes, so we'll need an email.
Okay.
We'll need a first and last name, and then we'll need a location of that.
Okay. All right. So I am going here to make a few comments. What I have added here are so-called slots. And in order for this to work, I'm going to import from Metaspex the slot abstraction. Okay. So what is a slot? It's an old terminology for an attribute of something in the language of ontologies. So here I'm saying that a prospect bears or has an attribute, which is the email, as an attribute, which is the last name, and as an attribute, which is the first name. All right. The first parameter of slot is the type of the attribute, so it's a string. The second one is a tag, which is going to be used in the database. So it means that the prospect, when it will be saved in Couchbase, will be will be a value prefixed with a key, which is specified here. So in the database, we'll see email the same way that we are going to see this string, which is a prospect. Okay, so we have the email, we have the last name, and we have the first name. You said location. Let's do it simple for the time being. It could be a geolocation and these kind of things. Let's put an address for the time being. And I'm going to import from Metaspex a ready-made address. So what is a ready-made address? It's something that we already defined as a bit of an ontology. And the magic with Metaspex is that we can reuse bits and pieces of ontologies as soon as they are defined. So with Metaspex, you are able to capitalize upon the bits and pieces of ontologies that you define. We have many ready-made ones. We have geolocations ready-made, which are HTML5 compliant. We have matrices, time series. We have a ton of them, but you can even reuse yours. So here I'm picking up an address, and it will have a first line, a second line, and a zip code, and so on. And it is ISO compliant. It has all the country codes as well. In order for this to appear inside the prospect, I have to write something different. It's not a slot, because an address is something which is structured. So I'm going to use another construct, which is own. I'm going to say that I own an address, and this is it. So I'm going again to import this. We sort them by name. And what does it mean? It means that the address and the prospect will be stored in the same document in the database. So own actually shows a relationship between two independent objects. You could, if you want, cut an address from one document, paste it into another one. So the address and the prospect somehow live independently. But here, own says that they are going to be stored inside the same document. Is it clear what I am saying? Yep.
I'd say so.
Yeah. Okay. So I'm going to list everything that I declared here: last name, first name, address. And I think that I could already compile this. Let me check. So it doesn't compile for one very simple reason, which is that I need to prefix everything, all the constructs that come from Metaspex, to prefix them with Metaspex so-called namespace. So instead of doing this everywhere, because it would be painful, I'm going to be lazy and write that I'm using the Metaspex namespace. So everything will be prefixed with that prefix whenever necessary. I'm going to try to compile. Let me, by the way, share my screen. I'm not going to do it too often because it's painful with Zoom to juggle. So you see that there was an error. Now I am compiling. It's much better. It has compiled everything. And actually the application, which is extremely simple here, there are no web services, is entirely in one binary, which is here. You see me highlighting it. So it's 53 megs, which is kind of fixed price to pay, almost a fixed price to pay with Metaspex. And every time we are going to add more stuff in the application, including web services, we are going to see this grow at a very slow pace. Again, 290 services, web services, which is typically 60 megs, something like this. So we are going to add, if we were to add 290 services, we would add 8 megs only to that binary. When you think about it, 52 megs is more or less what you download when you are in a browser. You're downloading an HTML page with a few images. The entire application is smaller than that single HTML page, which is kind of surprising. So I'm going to switch back to the editor. Sorry for this. All right. So it's here that it's going to be a little bit boring. I'm going to add a way to build a prospect from email, last name. I'm doing it in any kind of order. It's not very logical. And an address. So here, what I'm talking about here, so everything is unsurprising, except for maybe picky C++ developers would like to see something like this, maybe. I'm not going to do it. I want to keep things simple. The only surprising thing is maybe this. So this is also coming predefined. This is a smart pointer to an address, and it's a specific flavor of that smart pointer. It's an R, meaning that it is never going to be null. So it means that when you create a prospect, you have to give an address, and that address cannot be null, meaning that it has to be present. All right, and we are going to define this kind of smart pointers for the prospect type in just a second. So email, I'm going to assign the email to the slot, the last name to the slot, and the address that we got. Let me try to compile. Yeah, I got lucky this time. It's all good. So here I'm going to define a few accessors. And I'm going to say get last name. And the address. So own can be null. So in order for me to return an R, as I explained, which is not null, I am adding a star here. So nothing extremely surprising here. Check that it compiles. Yeah, everything is fine. So sometimes you may have to change the email address. Let's say that you mistyped it, that you, Ratan, you forgot something, or you were talking over the phone with a venue, and actually either they didn't know their email address very well, which I hear has happened for you a number of times, or you just mistyped it. So you may have to change the email of a given venue. So we need a set function. And that set function will just assign the email. So with that function, I'm able to change the email of an existing prospect. So this is something that requires a little bit of a comment, in the sense that here I'm just writing the specification of what is this assignment. If in some of the web services you retrieve a prospect, you change the email address, Metaspex will notice that you have changed it, that the document is dirty or has a change, and at the end of the web service, it will automatically save it to the database. So there is really nothing to do. Here, no SQL is written. It's just specifying exactly what is a change of email for a given prospect. I'm not going to do the other ones, but that's what's happening. If in that web service you just changed the zip code of that prospect, it would be exactly the same. So the address type which I have imported from Metaspex, contains a change of zip code function. If you call it, Metaspex will see that this address has been changed, that it is inside a prospect document, and that that prospect document needs to be saved at the end. So you have to say nothing, essentially. Metaspex is taking care of all this, and it sees that you have been modifying a document. If you retrieve a document, you don't change it, and the web service finishes, Metaspex will know that the document is clean, it's not dirty, and it's not going to save it. So all this is actually automatic. So essentially what we have been writing in this ontology is something which is purely declarative. We are declaring what is a prospect in your sense. So you said contains an email, contains the last name, contains the first name, contains an address. And I've just been outlining this in code, which technically happens to be 100% pure C++ code that I am compiling with at this time, G++10, a pretty old C++ compiler. Very happy with what it is here. So now we may have to manipulate prospects. We are using smart pointers to do this. So I'm going to declare the smart pointers. So I'm just saying we are going to have a class prospect in the ontology. I am going to define the smart pointer prospect P and the smart pointer prospect R. The first one can be null, the second one cannot be null. And when a smart pointer is not null, it actually propagates a bit like a virus. So you don't have to check if something is null or not. If you receive something which is not null, and you send it to somebody else, all this is going to go through smoothly, and nobody has to check whether a pointer is null or not. An advantage of using these constructs, which actually come from Metaspex, is that it's doing memory management for you. So you never have to delete memory explicitly, and deleting things explicitly comes with a number of possible bugs. It's actually relatively dangerous. So it's done automatically. It's using a technique called reference counting, and reference counting is known to have a number of advantages. Consumes very little memory, and you can testify that the backend consumes extremely little memory in production. Even with 5 transactions a second, it's extremely small. But they come also with a problem, which is that with reference counting, you cannot have cycles. Rust, for instance, the programming language, uses reference counting. It's not using any garbage collection, and you can make cycles. With Metaspex, we don't have this problem. So objects are automatically destroyed, and still cycles are allowed. And we do not have an expensive algorithm to look for cycles. I cannot give too many technical explanations on this, but we are not using garbage collector, and we are not scanning the memory. We do some scans, but these are limited to documents, to a limited number of documents. Okay, so now I can manipulate prospects, and I have both the P smart pointer and the R smart pointer. So now what I can describe is an interaction. So what is an interaction with a given prospect? It's the same thing. I'm going to describe what is an interaction. We could store all the interactions for a given prospect inside a prospect document. So it means, because this is limited, you're not going to speak to a prospect 10,000 times, hopefully. But I'm going to do it the expensive way, which means that I'm going to store each interaction in a separate document. This, in theory, on paper, scales better, in the sense that you can really have many interactions with a prospect, and we are not storing the interactions in its prospect document. We could. It's not a big problem. The question to ask oneself is whether the relationship between a prospect and an interaction is a one-to-few or a one-to-many. Here, I am kind of assuming it's a one-to-many. Don't ask me to define few and many. It really depends on the application. It's more of a kind of a gut feeling than anything else. So here I'm assuming it's not a one-to-few, and it could be debated whether it's a one-to-few or a one-to-many. So it's a one-to-many, separate document. So now you start being used to it. I'm going to say it's a root. And I am going to use the same macro. Give a tag type to this, which is unique. So I cannot use the same as prospect. It's the first version. Contains a number of things that I'm going to list after. So one that I don't need to ask you any question about. There was a quote, is the relationship between interaction and a prospect. The relationship is something that establishes a way to relate an interaction, which is in a document, to a prospect, which is in another document. Believe it or not, document databases do not offer any possibility to do this except doing it by hand. So we are automating this. This is something that you find in graph databases. This is something that you find in good old relational databases. Funnily enough, document databases have only the own, if you want, which means that there are things contained within the same document, but nothing between documents. So this is kind of a URL, if you want, between two HTML documents. And we have a construct for this. This is a link. So it's a link from an interaction to a prospect. And here I'm going to give a little string, which will appear in the interaction document. And I call it prospect. Okay. And here, prospect. So what does this mean? It's like a URL. So it means that if you end up somehow on an interaction document, let's say you show an interaction in the app or in a browser, if you cross that link, you will obtain, and Metaspex will make sure that you obtain a prospect and nothing else. It is strongly typed, meaning that you cannot establish a link between an interaction and an address, for instance. It has to be a prospect. So it means that when we describe ontologies, we describe things that are so-called strongly typed, meaning by this that the compiler will check that you make no mistake. We are not claiming that once the compiler has finished its work and verified all your specification, we are absolutely sure that the application will behave properly, but we have a good amount of certainty that the application will behave. At least we'll have what's so-called type safety. So this is the link with a prospect. Of course, when you are going to record an interaction with a prospect, you want to record when this interaction happened. That interaction could have happened a day before, 2 days before, something like this. So maybe not at the moment when you are recording the interaction. So I'm going to store the timestamp of that interaction. And here I am going to call it a timestamp. So I'm using a slot here as well. And it means that every interaction will have a property, which is the time when it happens. For the people who know what a time t is, this is a Unix epoch, which means it's number of seconds since sometime in the past in the 1970s. That's a very objective way to store dates and times, and that's what we are using in the entire Venue application. If you want to display this in a browser, for instance, most likely you will display it using some JavaScript code, possibly in your apps as well. And JavaScript as a way to show exactly in the time zone where the person is watching that timestamp, exactly the date and time where this interaction happened. So if you, Trent, or somebody else consults all the interactions, you will see it in your Austin time zone, for instance, while Ratan will probably see it in the EST time zone. So time T is good for this. I have not imported the link. So I'm going to import the link. An additional thing which is very useful with link. Link is a very big abstraction in Metaspex. Metaspex has 300,000 lines worth of abstraction. Link is one which is pretty sophisticated. What does it do? In addition to what I was saying, which is establishing a relationship between two documents. It's doing what we call referential integrity. And what it means is that this link, being a strong link, an interaction can only exist if the prospect still exists as well. In other words, if I remove a prospect, all the interactions with that prospect will be removed from the database automatically, which is very powerful. And it's also saving a ton of code, which can be very error prone, and you can make mistakes, and you need people to test, and all this testing will not be necessary, except if you want to test Metaspex itself. So this is actually doing referential integrity automatically. Relational databases used to have this kind of concept, but it was tied with the disk almost, with the schema of the database. You didn't have the flexibility that you have here. And this is much more sophisticated than what I was talking about, but I don't want to go into the details. So just remember that link is a pretty powerful thing. It's not just storing some kind of idea that shows that the interaction pertains to some prospect. All right. Everything clear? Ratan, no question?
Vincent, you were telling about maybe like one of the option was adding prospect within, say, sorry, adding the below interaction within prospects, right? How would you have done that? Maybe not code it out, but just like, quick overview.
Yes. So you mean, if I understood well, and correct me if I misunderstood, it's either companies or people that you talk to. That's what you meant?
Yeah, like you said, right? There's two ways. Rather than using the link that you mentioned, directly defining
Oh,
the
sorry.
other
Now I understand. Now we
document within.
Yep. So the way I would do it if I was to store the interactions inside the prospect, I would use own, because own is the relationship that shows that things are stored in the same document. So I would use own list, interactions, and interaction. That's so it's a variant. We have many variants of the relationships. Every relationship that starts with own means origin of the relationship, here the prospect, and the target of the relationship, here an interaction, will end up in the same document. See? So, and I would remove the link from the interaction. It's not needed.
I see. So then the link part is not required directly. If you define the interaction and write the own, it'll paste that document within this document, right?
Absolutely, exactly. And technically, it will not be a root any longer. So I would take this interaction, move it up in the document, and I would, because it needs to be declared first, logically, because the prospect will contain it. And I would make of it not a root, but an element. We have a different construct, and an element is something that can appear inside another document. Typically, if we were to see the specification for address, an address is an element. It's not a root. Yeah. So I would just do this, and I would change, of course, the macro and so on, just a few details, and then it would work.
I see.
Okay. To answer the question that you didn't ask, and I thought it was your question, which still deserves this. So this was a trans question. How would we do so that a prospect can either be a company or an individual? And what we would do here is that we would use inheritance. We would say class person prospect, public prospect, and so on. I'm not going to give details about this, but that's the way it would be done. And then I would have also a class company prospect with its own data, because the data for a company, you may want to have some kind of description which does not exist for persons. And everything would work. It would go in the database and we would save it properly. We support entirely inheritance in ontologies, completely, including inside relationships. All right?
Mhm.
Yeah. Another thing about link. When you specify a link like this in the ontology and you describe some business process later, imagine that somehow you are able to acquire an interaction. If you want to do things or inspect things on a prospect, the prospect that this interaction pertains to, you would just cross this prospect link. And by writing, if I is an interaction, this would be a prospect. And there is nothing to do. There is nothing to write in terms of SQL. There is nothing to use in terms of database API or whatever. It will find it and it will return it, and you can access its name, its last name, its address, and whatever. Okay, so this is why link is pretty powerful. It's doing referential integrity, meaning that you just have to remove a prospect when you want to remove all the interactions pertaining to this prospect. But also, it is doing all the queries to the database to retrieve a prospect when you need it. Right? So it is extremely, extremely simple. Another thing also, which kind of goes without saying, and therefore I forgot to say it, is that here we have enough to have a prospect and an interaction persist in any database of your choice. So it means that all this, as is, without any change in the code, can persist in Couchbase, can persist in MongoDB, or can persist in CouchDB. The choice of the database is made in a configuration file. So it's not, it's even no need to recompile the binary. It's the same binary. And if we go see the configuration file, I already prepared one. Here we can see that we have a logical name which is associated with, in this instance, Couchbase, and there are some credentials and so on. But we could as well have in this Metaspex configuration file the fact that this database is a MongoDB one or is a CouchDB one. Same thing, same binary, you just change the configuration file, you restart the application, it will save things in MongoDB, for instance. Extremely, extremely easy. So this is why we actually cannot use any database API in the specification. It's because it's not tied to a given database. So it saves a ton of code, but also it is not specific to a given database. We don't use SQL for one simple reason. CouchDB, for instance, doesn't have any query language. MongoDB has its own. Couchbase is something which is very close to SQL. You don't need to use it. Everything you saw will work on CouchDB without any query language whatsoever. It will work all the same. And just to show off, it's probably not useful, but you never know. When you have a link like this link establishes a URL between two documents. It can be between two documents in two different products. So the prospects could be in MongoDB and the interactions in Couchbase. We don't care. And we run referential integrity across different products if we need to. When we run referential integrities, another thing also is that if you remove a prospect, all the interactions will be removed. We do that without using any index. zero index are involved when we do such a thing. So this is why we can have extremely fast response time, typically with the new backend. Worst case scenario, it's 2 millisecond, 3 millisecond response time, sometimes microseconds because we don't go in the database. This is one of the tricks that we use. In our sleeve, we have referential integrity without using any database index, which is makes it extremely fast. All right. Let me do the same for interactions. Any other question?
I got nothing.
Okay. Trent, you are not a developer. I'm interested in your take, and you can be very critical and so on. I guess that code is not necessarily what you prefer in life, and that's and you're doing what you are doing beautifully, and so it's not a criticism at all. Huh? But do you find it very obscure, or do you find it relatively normal and not too shocking?
Yeah, I think, one thing that I differentiate this in comparison to other softwares that I've tried to either learn or try to be a part of is, a lot of like the nomenclature that exists in here and just kind of the different syntax seems a lot
Yes.
easier to kind of go through.
Yes.
Obviously, working on it and working with it before we have experiences with it, whether it be at its best or at its worst. So it feels like at its core, it's always simple, which is something that is very kind of essential. And I feel like that's something that we need to get across. And I feel like you guys are doing a good job of is keeping it simple and just dumbing it down as much as possible to where you almost don't even need to know software to be able to use it.
Yep. Yeah. We try to keep it simple indeed. There are a few repetitions here and there. Maybe you noticed them. We are trying to reduce them to the maximum. We really intend this to be a specification, a formal specification. It's granted, it's code, but it's also documentation in the sense that Ratan's experience to implement web services that are shown by the backend is actually to read the specification to see what he needs to send from the app and what he's expecting as a reply from the web services. So without having received any training on Metaspex, Ratan was already able to use and leverage the web services from the backend, which is very interesting in itself. Let's write a service.
Cool.
Let's write a service and let's create a prospect. So when I say web service, what is it? It's something that relies on HTTP, that can receive a JSON payload and reply something which will be JSON as well. We are not going to add any security around this. It's very easy to add, but it would be a distraction. We are just going to describe a service endpoint. When this service will be described, the binary that you saw, the 52 megs binary that you saw, let me check, by the way, the size. It's still 52 megs with the little things that we have added. That binary will run inside a web server. So in your case, it's Nginx. So you're just taking the binary that I showed earlier, putting it inside Nginx, using Nginx for all the HTTP configuration, HTTPS, number of threads, and so on. And then it will be able to serve a web service, which is the one we are going to deliver, to develop here, which is to create a prospect. So something very simple. So the way it's done, we declare a variable. So it is, let's say, prospect create service. We are using a construct which is service that I need to import. And here I'm going to give it a name. So this is the endpoint. I'm going to explain what it is in a second. So at this stage, I'm going to add a few things, but what I am describing is something that is going to answer to a service call in the form of HTTP. Let's say you do it from the same machine, so it's local host, but it could be remote from Australia. A port number which is configured inside Nginx, so outside of all this code, and then the service endpoint, which is prospect create, which is precisely what I wrote here. So anything I write here will appear as the service endpoint. So if I'm using, for instance, if you're familiar with Linux or some other operating system, I could use the curl utility to actually call this service. And it would work. You can call it from any programming language. You can call it from JavaScript. And that's the way you're currently interacting with the new Metaspex backend. Of course, when you make a service call, you need to send a payload. So typically, you need to give here the email, the last name, the first name, and the address of the prospect. And all this is totally custom. As you can see, I've specified the web service endpoint, totally custom, whatever you want. And then we are going to specify what is the payload that you need to send for that web service call. And it's going to be any kind of arbitrary JSON message, but we are going to describe it using a very strong type. So in order to create a prospect, I'm going to continue my code. I am going to write some little incantations, and I am going to use a prospect, a type which is describing the payload. So let's say a prospect create payload. It needs to be present, cannot be null, so it is an R. And I am going to describe what it is doing inside this. Okay, so bear with me. Okay, so I think I just need to write here what prospect creation does, and I will fill it up later. Because first I need to describe this. So this is the payload that we want to carry. As I said, it's going to be strongly typed so that we don't mix, apples and pears. And I am going to add some payload to this. So the way to describe a payload is something that you should be familiar with. Class prospect create payload. This time it's not an entire document, so it is an element. And I'm going to add this. Prospect. I give it a name. There is no version number this time. It's an element. It contains a number of things. Okay, so what does it contain? In order to create a prospect, what you need is, as you said, an email. You need a name, last name, a first name, and an address. So slot, you need an email. So this string here will be the JSON key to be sent by the client. It is distinct from the one I used here. Here, for instance, I could use something shorter. I could use E, LN, FN. This is what's going to be stored in the database. This is what's going to be exchanged between the client and the backend. So typically, if it is your iOS app or if it is a browser, most likely a browser in this case, the JavaScript code will have to send something with this email. Okay? I'm going to copy the rest because it is exactly, in this case, it is exactly the same. It can be different. Okay? And let's say that we want to be very verbose because Ratan will make mistakes and he needs to be able to debug them, just pulling your legs. Okay, and so here we have email, last name, first name, address. And as it stands, now this web service will be able to receive, if it is curl, it will be like this. It will be a JSON message containing email trent@chili.com. Probably does not exist.
I tried. I couldn't get it.
Too bad, too bad.
Tried
So
my best. I couldn't get it.
apologies for the person who owns this. First name, Trent. Last name, Chili. And address, which is a JSON structure containing everything that the address proposes. It's in Metaspex documentation. I'm not going to dwell too much on this, but there are a number of things, including the recipient, the first line, the second line, if it is existing, the zip code, the region, the country, and so on. By the way, I'm just going to write the country. So if it is the US, it's 840. You can see that this is a number. It is not between double quotes, so it's not a string, it's a number. If you call this web service and instead of giving 840, you give 840 between double quotes, the backend will refuse it. We'll say that cannot pass this country code. So a lot of things are actually verified. So let's create the prospect from this. So here we assume that Metaspex has received this payload that you see above, and it will be able to pass it according to the structure that we described. So it is very, very strongly typed. We need to create a prospect. First thing we need to do is to connect to a database. Okay, so here I'm using the logical name, which is hx2a, which is declared here. So Metaspex will know after reading the configuration file that it is actually a Couchbase database. Okay, so we need to connect there in order to create it in that database. I am going to reuse the address. So so I'm using the query here. So what is here? And I need to access the address. So it's public. I'm going to be able to do it. It's a own, so I can use this. And a own can be null, so it's actually an address in this case. So here, I'm just taking the address from the payload, which is fully typed, fully parsed and analyzed by Metaspex, and I'm using directly the address. Here again, types are checked, completely checked. I'm going to do something which is this, because the address is inside the payload. It is owned, literally, because it's owned by the payload, and if I want to reuse it to create the prospect, I need to cut it away, just like you would cut something from a document. Then I need to make a new prospect. So I'm going to make a prospect. And I'm using a Metaspex abstraction, which is make. I'm saying where it needs to go. And if you remember, I had a constructor. So to build it here, I'm going to list everything that I'm taking from the query. Email, last name, first name, and the address. Okay, and that's all. This is perfectly correct Metaspex code. You don't need to call any database API. You don't need to use any SQL. You don't need to specify how to represent a prospect into some JSON document inside Couchbase. If you had chosen MongoDB, it would actually serialize it into Bison. So you don't care about this. You just explain that you are, in this web service, creating a new prospect. That's all you have to do. Here, as it is not returning anything, by default, Metaspex will return to the client side the empty JSON object. So curly braces opening, curly braces closing, that's all. We can actually return something. So let's go to the beginning. Let's say that we want to return the ID of the prospect. Metaspex is adding a number of metadata to every document. That includes a unique ID, but that includes also the creation timestamp, the last time it was updated, a number of things. So here we have a ready-made abstraction. We have many, many types of canned replies. You can define your own replies. And we are going to use reply ID. This will return the document ID, which happens to be 128 bits UUID, that Metaspex allocated automatically for this. Okay, so to return it, we just write return make reply ID, and that's all. And what this will reply to the client is something which is specified in the reply ID payload, which is something containing a number of digits, and this. And that's all. There is no memory which is being deleted, at least not explicitly. And we have defined our first web service. I'm not completely sure that it compiles. Maybe it requires some touch-ups. Yes, it does require some touch-ups. I will fix it after. But that's it. So we have defined our first web service with this, which is kind of interesting because it didn't take much. We have given a payload here that we can reuse for other web services. You know, we could give it another name, we could use inheritance, and this could be used, for instance, as prospect data. So if we retrieve a prospect, we can actually return that as a reply, not as a query, but as a reply. And then it will return to the client everything that a prospect contains. All right. Let me add a little thing. Okay, let's change this and say exactly what I was saying, which is instead of create, these are data. Sorry, this is create. So in order to create a prospect, you sent it some data. Okay, so this is this. And let's create one more service, which is the client asking to find the data corresponding to a prospect. So let's do exactly this. And I think we'll stop there because we have been running a little bit over time. I've been talking too much. So this is another web service. I call it prospect get. And here I am going to use something which is allowing the client to send a document identifier. This is a query ID. And we have it here. So this is already a second service. We are going to connect to the same database, otherwise we are not going to find what we want. And we are going to just return prospect get from the database. I think that's the way it's done. So here, if I do this, which is just 2 lines in this process, if I call from the client, let's say it's the way I've done it, prospect get, and here I say this is the UUID that I want. This actually will return the entire prospect. So it will be something with email, etc. Okay. So we could go much further, but this function is actually supplied by Metaspex. You don't need again to run any SQL or whatsoever. It will take the UUID. It will not use any secondary index. It will be extremely fast. That's why ontologies are extremely fast. And it will return the prospect that the client wanted. It's 2 lines. That's all. You don't need to delete it. You don't need to care about its lifespan or these kind of things. It's just straightforward. All right. Any question?
No, Vincent. I think
Okay.
Good here too.
Okay, very good. I could also return something that is, so if I wanted to have specific data and not everything and something like this, I would have the constructor here taking a prospect, and then I would we have defined all these functions. And here I need to copy it, the address, because it's owned by the prospect. And provided that I did this, which explains how to build prospect data from a prospect, here I could write return make prospect data of prospect get Okay, and of course that prospect might not exist. So in order for me to cater for this, I would have to write something like so this means that if I send something which is not a UUID, you will have a parse error. It will be refused, so it needs to be a valid ID. Metaspex will report it. If that ID does not correspond to an existing prospect, then there will be a graceful JSON reply saying there has been an exception and the document does not exist. And if it does, it will return this prospect data, which is specified here. So I could filter out, for instance, if I don't want to have the email address, I just have to remove it from prospect data, and it will be filtered out. This is something that typically people use GraphQL for, and here it's absolutely not needed. It's extremely simple to actually eliminate or add information to any kind of reply from the websites. Okay, so pretty simple. I know it's a little bit foreign because you have never seen things like this, but after using it and using it over and over and over, you actually get used to it, and it comes extremely easy. It cannot be made much smaller than this. This is why we call this a specification. It's very concise. And if I make a mistake somewhere, let's say I don't write prospect data, but I write, I don't know, interaction here, the compiler will refuse. It will not let the binary be built, and that means that you have a number of assurances that the application will work. Not perfect assurances, absolutely granted, but assurances nevertheless. And we have an homogeneous way to describe the payloads, where the query replies, and the ontologies. As a matter of fact, the distinction between what is an ontology and what is a payload is actually very blurred. These types could be used to persist or be sent across the networks. It's all the same. We just tend internally, and you don't have to do this, to write in the ontology things that do persist in the database. And in the section which is payloads, only the things that are transient, that are carried between a client and a server. But it's just our OCD, and that's the way we do things. By all means, you can do things differently. So all this is supported by our reference guide. All the constructs that you see are documented with all their details, all the API. You can see that here, as I said, no SQL management, no memory management, no network, no JSON, no Bison, no threads. This application will respond in a few milliseconds. Realistically, will use a tiny fraction of one core in AWS or any public cloud. The executable will be very small, and it will be very light to operate it. If you want it to scale to 128 cores in any public cloud, you just write 128 in Nginx configuration file. It has no incidence whatsoever on this code, and it will stretch to 128 cores. Or if you are hosting your application in an HP Superdome with 896 cores, it will stretch to 196 cores without any problem. And it's a little bit bizarre, but the binary will be 60 megs, but it will run on the Superdome and make perfect leverage of the almost 1,000 cores that HP Superdome is offering.
Good stuff.
All right. Any more question?
I'm all good.
All good. Excellent.
Yeah, same here.
Okay, so I was very ambitious. I thought that we would develop 10 web services. We have developed 2. Probably talk too much. When a Metaspex analyst is developing, they are developing much faster, obviously, than what I did here, because all the question and answers had been made prior to this. So typically here we have reached 112 lines. We have seen up to 800 lines per day. So 800 lines per day is 8 times this. So typically here 2 web services, 8 times 16 web services in a day. Most commercial applications have a few hundred web services. They don't have a few thousand web services. So this is why people in the audience need to realize that you can make extremely complex applications with this. Again, you have seen not even 5% of Metaspex here. We have many, many more constructs in the library. It's 300,000 lines of code. So obviously this does not require 300,000 lines of code, but already you can see the magic. Means that people who are even hardcore C++ developers may wonder how such a thing is possible reading this specification. There is some magic happening, and it's taken us a long time to hide all the technical details and at the same time make them extremely, extremely fast. Faster probably than anything you can do by hand in a reasonable amount of time. And last but not least, it's very safe. Everything is verified by the compiler. I will not have to have many touch-ups on this source code to make it run. It's going to take me offline maybe 5 minutes, and everything will run perfectly. All right, guys. Thank you so much for your attention. I hope it was not too boring. We can do another one at your convenience.
Cool.
Yeah,
Sounds good.
thanks, Vincent.
Okay.
Thank you, guys.
I'm happy.
Bye-bye.
Thank you.
See
Bye.
you. Bye-bye.
Goodbye.